A few videos ago, we talked about the factor theorem, and we basically said that if you do f at k, so f at some number, and you get 0 as an answer, that you could say, therefore, x minus k is a factor. And I said that this factor theorem was related to the polynomial remainder theorem, and that's the theorem I want to go over today. So, polynomial remainder theorem. And really, the factor theorem is a special case of this, right? Because if you look here, you have a factor x minus k. That's the number you're dividing by, right? That's the term you're dividing by, I should say. And the negative k there, if you were just to plug it in, right? If you just plug in the value of k into your function, you get 0. 0 is the remainder you get when you divide by a factor, right? So you can probably guess how the polynomial remainder theorem works. If you have some polynomial, so I'll just say you have a polynomial, and the polynomial is f of x, and you do f of x divided by, and then you have some binomial, right? And the binomial is g of x. So if you do f of x divided by g of x, you get some answer, right? You get some answer plus a remainder over g of x, right? That's usually how this works. You divide two things, you get an answer plus a remainder over this, right? We covered that in our division video. Now, there's a way to find this remainder without going through all this trouble of actually dividing, right? There's a way to do it, and that's using the polynomial remainder theorem. All you'd have to do is say f at, and then you plug in the number from g of x. So not g of x, but like if g of x, for example, was x minus 2, just as an example, then you'd plug in 2. That would equal your remainder here. Which seems crazy, right? Like it doesn't seem like that would do anything or that would work. But if you think about it, it works up here for the factor theorem, right? When you plug in the value k from the factor, you get 0 because 0 is your remainder when you divide by a factor. It's also true that if you plug in any number from a binomial you're dividing by, that is going to equal your remainder. So if you just had to find the remainder, you don't care about anything else, you could use the polynomial remainder theorem. Now, if that's confusing, let's do an example, and I think that'll probably clear some things up. So let's say you have f of x equals x cubed plus 2x squared minus 4x plus 7. And let's say you're asked, what is the remainder when you divide by, let's say, x minus 1. Let's say that's the question. What's the remainder when you divide this by x minus 1? All you have to do, you don't have to actually divide it and then find the remainder. All you got to do is say f at 1, and this will give you the remainder. So you do 1 cubed plus 2 times 1 squared minus 4 times 1 plus 7. So you get 1 plus 2 minus 4 plus 7. That's 7, 8, 9, 10 minus 4 is 6. So the remainder is going to be 6. And you could confirm that answer, right? We're not going to actually do it, but if you wanted to, you could set it up, either long division or synthetic. You could say your x cubed plus 2x squared minus 4x plus 7, your x minus 1. You'll get some answer up here, and at the very bottom, you're going to get 6 for your remainder. So you could do the long division to check, or the synthetic division, same thing's going to happen. But you don't have to, right? You can just do this process here. All right, let's do another question. What if we have f of x equals x cubed plus 2x squared minus 4x plus 1, and let's say we're going to divide by x minus 1, and again they ask us what's the remainder if we do this. So all you do is you say f at 1 once again, and you get 1 cubed plus 2 times 1 squared minus 4 times 1 plus 1. Well, what happens here? Well, you get 1 plus 2 minus 4 plus 1. Add these together, you get 0. So the remainder is 0. Now, if you do this and the remainder is 0, then you can draw the conclusion that therefore x minus 1 is a factor, right? So again, the factor theorem is just a special case of the remainder theorem where it happens to work out to 0, right? Where your remainder is 0. Hopefully that makes sense. And then you can go ahead and confirm that, right, by dividing. You could set up your synthetic division. You could say, your 1, 2, negative 4, 1. Put your 1 out there, so we're just doing the actual division. If you do this, you're going to get a remainder of 0. just like you got here. So you can easily confirm your answer if you actually go through the trouble of doing the division. Okay, so hopefully that makes sense.